this audio is not great, so trying to sort of generally speak that way.
There is pizza here if anybody wants pizza. Okay, all I need is I think we're starting to talk in a few minutes or so it's robotics and you're soldered it up herself. Definitely wasn't just soldered out against a fully soldered circuit board that was made. Did make the pressure sensor himself, because there was time to do that, time to make some code board and what have you. And then took in their shoes and was on the side bike, getting encouragement and makes you pedal fast and audio makes you pedal slow and congratulations if you pedal fast. So there was, pressure sensor was reading data, streaming it over MQTT or Wi-Fi, and then there was a graphical stuff to show pressure was something, so there was a bit of that, but then also going on the five that was using that working out presses, cables and completely sure that it was working on quite properly because it seems quite high. Right. Like compared to when I've had the cable speaker on my bike. Yeah. Not massively, but just a little like but it didn't really matter. It just needed to be like when I was pedaling, I was like, okay, yeah, quite fast. So I'll get it above to go like. Is it really well? Well, yeah, all about that, but even mind that, it's already so yeah, it should be on the 3rd of May. So that's it. So on the 3rd of May, you'll be able to go on to the catch-up and watch it. I think it's a more general piece about speculation. Well, that's I think what was is more. It's cool that you can buy and then they sacrifice like well actually. If there's a thing that you want that you can't buy, you can go to places like this and you can find out how to make it yourself. Yeah. Yeah, it should be. Give me an interesting couple of minutes. So, they might not be cricket. So they're like, oh, turns out everyone's just going to show up and So now that we've got Alex to get everyone's attention, or maybe not get everyone's attention, you got it for something other than getting pizza, Alex. Hello everyone, welcome to IoT Local. Have yourselves pizza and drinks. I'm Adrian. Oh, that's really very important at all. Yeah, cool. And welcome to Does Local if you've not been before. We're a co-working makerspace as well as the events room, which you're in a minute. So if you want to have a look around any of the rest of it, give me a shout after the end of the talk and I'll give you a bit of a tour. So we've got officey kind of desks and stuff, you know, the co-working stuff is just desks you put stuff on. But then we also have 3D printers and laser cutters and CNC routers and soldering irons and oscilloscopes and all manner of kind of exciting things. So once you've been inspired by Marty to build robots, you can come through and find out all of the tools you might need to build robots. So that should all be good. Kind of other housekeeping stuff, we're not expecting a fire alarm. If the fire alarm does go off, the fire exit is out the way you came. And if for some reason that's blocked kind of through the other side of these sort of windows, you go round to get to them. You wouldn't go through the windows, I don't think, unless it was a really bad fire. And across, and there's a fire escape out the other side. And toilets should be in either some at the bottom of the stairs or, again, towards the fire escape. If you find yourself outside, you've gone too far. But the toilets would just be full out. Yeah, I think mostly what I need to do is just introduce Marty, who's going to be telling us this evening all about the robot operating system, I think. Is that what ROS stands for?
Yes.
Excellent. I do know something about this. I don't know very much else, but I'm going to learn along with the rest of you. Thank you, Marty.
Okay, so, well, I am Martí. Some of you know me, some others don't. So I come from Barcelona. There I was in a robotics lab for 5 years, and then I came here 4 years and a bit ago, and currently I'm working in a company in the nuclear industry and doing robotics in there. So what I'm going to explain to you today is about ROS, which is the robot operating system, as Adrian said. So we are going to start. So basically, okay, a bit of a summary. So we have what is ROS, examples of robots. Then I'm going to show you how to build a robot application. That's going to be a little bit of a mix between explaining you how things work, but also showing you things working. So I'm going to go through different ROS concepts through examples, showing you simulations and the ROS tools that this software gives us. Later, since this is the Internet of Things, I'm going to talk briefly about ROS and web, how you can make robots that are connected to the web. And also a little bit of drawbacks of the system and future of the system. And at the end, few first steps if you want to start building your own robots with ROS. Okay, so what is ROS? So ROS is an open source operating system, framework called Robot Operating System. So what is a framework? So a framework is a collection of tools. It's also a collection of libraries and a way of doing things. So it's not just a piece of software that you download and you execute and it works. It's much more than that. It's a way of making things for simplifying robot software development, distribute tasks, because robots are complex. Usually they can have like one single computer for the whole robot, usually are distributed, or maybe you have people in a control room and they need to see some things of the system and not being in the robot, things like that. The other thing that is important about ROS, and one of the design motives of ROS, motivations behind ROS, was avoid reinventing the wheel. So what happened for a long time, it was that a lot of software developers for robots, they were doing the same thing again and again and again, and people were doing the same kind of communications between robot and computers, and what ROS showed it was that you didn't have to reinvent the wheel. You could have a set of standardized tools and then build on that. So instead of having to look at every single part of your system, you could decide to work on the part that you are more interested to. The other thing is to encourage collaboration. So since it's an open source software, it's open. So people from everywhere can download it, can check it, can fix it, can find bugs. So that's really good. And also it has quite a big community behind. So we have forums and other tools. So when you have a problem, you can go there. Some people will have asked a question or not, so you can ask questions there, propose new things, interact with other people from around the world, and all with the same objective. So ROS comes from, now it's a foundation called Open Robotics. But the start of it was this robot. So this robot is the DR2. So it was made from a company which was a startup of Stanford called Wheel Garage. So Wheel Garage decided to push some boundaries in the robotics research, and they created this platform which it's quite cool, and it has a lot of sensors and actuators and things. So this is just a few of them, it's not all of them. So we have stereo cameras on top, we have lidars that tilt in the neck, we have IMUs, which are inertial measurement units, so we know which is the orientation and angular speeds and accelerations of the robot. It has 2 arms with cameras in their forearms. It has a telescopic body, so it has another motor that moves the body up and down. It has lidars at the base also for navigation. It has 4-wheeled base with a lot of computing in there. There's like, I think we had 7 computers in there, so it was very, very heavy. So what happened, it was for this kind of platforms, they needed a software that was very modular, that it was very flexible, and this was the platform that ROS really was designed for. So that was the start. So which robots use ROS? So there are ground robots like this one, which is a robot I was in charge of when I was in Barcelona in the robotics lab. So it was called Theo, and it had custom sensors, it had sensors off the shelf that we bought from different suppliers, and it was used for research in exploration and navigation. So why we use ROS in this case? At that point there were other options. There was one called YARP, which was an European middleware, which means I think it's yet another robot platform. But ROS had something really good that the other one didn't have. It was the documentation. So ROS was very well documented. It was very easy to follow the tutorials, understand it, and build on top of that. So there are other platforms that use ROS. There are underwater platforms, aerial platforms, even in the space. So the Robonaut 2 from NASA uses ROS. I'll put the slides online somewhere. In the speaker notes, you have links for all these robots if you want to have a look at them. This one is a humanoid robot from PAL Robotics. So that's 1.75 meters. So it's a bit short, no, a bit shorter than me, not much more. And it weighs 95 kilos, so that's much more than me. Other things, it's not only robots, but also, for instance, a robot hand is a Shadow hand from Shadow Robot, who they are here in the UK, in London. But we also have industrial cobots, like these universal robots, UR10. Or we have other more industrialized robot arms, like this one is an ABB. In this case, it's not that the company is creating the drivers for ROS, but the community and something called ROS Industrial has made the drivers to work with this robot, so it can be used with the rest of the platform. All these robots are quite expensive, most of them. They have really like cutting edge sensors, and the platforms, as people who make things, you really can't afford having those kind of stuff, but that really doesn't matter. That's my example today, so you have it here in front. So it's basically a bunch of cables and a couple of wheels and a Raspberry Pi. It uses a board to control the motors. That's from a guy who I think used to be here in Liverpool. Barry, yeah. So I'm going to show you how to build an application using this robot that really everyone can do. The cost of this is very, very low. So it's not that we need a very expensive hardware. Okay, so what is the application I'm going to show you how to create? So I'm going to make the robot navigate to a goal in a map. Okay, so what do we need to do that? Basically, if I go from low level to higher level, we need to move the platform. We need to know where the platform is. So this is called the odometry. So the platform has two encoders, which they detect the position of the tires, of the wheels, and with that we can calculate where the platform is. What else we want to do? We want to allow teleoperation, because to test and to make it work at first, we want to teleoperate it. We need to sense the environment in order to find where are obstacles and avoid them. And we need to find a path to a goal. So we need to know a little bit of how's my environment and then find that path. Also, we want to follow that path. We want to avoid obstacles, like static obstacles, but dynamic obstacles also. And we need to create and read a map and localize on that map. Okay? So, as I said, the platform has two wheels and a pivot. Transfer ball. So it's basically a ball that it doesn't go away, so it can move in any direction. But that's just to hold the robot in play. So this kind of robot is called a differential drive robot or kinematics. Basically, we have two wheels. When these two go in the same direction, it moves that way or that way. When one moves one direction and the other one in the other direction, it will turn. And if we have different speeds, it can do different radiuses. Okay, so from this platform I showed you, we have already that, so we can move it with velocity, and we can read the position of the platform via the encoder sensors. So I'll start with the next thing, which is the teleoperation. So usually when we have a platform like this, it doesn't have to be ROS, it can be anything. We can have an Arduino controlling two motors and have this platform very quickly done. But we would have something like this. We would have a joystick. That joystick would send a velocity command to the platform controller, which would move the motors, therefore the wheels. So you could do that with Arduino, no worries, that would be more or less easy to do. But what ROS do? So ROS basically, it makes things modular, so we want to reuse things. It's not anymore that we are writing our Arduino code and put it into the Arduino and that's all. We want to have a joystick that we can use with everything. Yeah.